property like in some sort of way of like containing the data so you can control how it's accessed and how it's utilized?
Okay.
You could, let's say, look at an atomic access, so it has to be all done at one time.
Okay, good.
While checking their data and doing all sorts of other things.
Okay, good. So to summarize for camera here, a property is essentially like a wrapper for an instance variable. And an instance variable, meanwhile, is a piece of data that's inside of some object. And it's a wrapper in the sense that you can control how that piece of data is accessed and also set by way of the creation of things that are generally called getters and setters, or accessors and mutators, which no one really says, but every textbook says it. Yeah, Jason.
You can also use dot notation.
Yes, so this is another compelling feature syntactically of properties, is that it allows you to start using dot notation. So that if you want to access some member bar of an object foo, normally you would say something like this, or rather, oops, that's the method syntax. If we say foo arrow bar, sort of C style, this would get us the instance variable called bar. But the fact that we now have properties means we can slightly simplify this to foo.bar, which is not a huge leap. You're saving one keystroke, which isn't all that compelling. But when you call it this way, what are you inducing when you access bar in this way? Jason?
You're essentially doing a message, so whether it's getting or setting.
Good. So you're actually invoking the method. You're passing a message known as bar to this, which is invoking the getter in this case. Or if we happen to have an equal sign over here, then you're invoking the setter. And the setter, by convention, has to be called what? For an example like this.
Set and then uppercase of the instance variable name.
Set bar. So this is a convention in Objective-C. And you can override these defaults, but generally this means your getter should be called bar and your setter should be called set bar. All right, so back to the story at hand. So we now have two properties here. One is called window, one is called UI controller. So let's take a look at this one. UI window just refers essentially to the rectangular glass. So in this template, you have some pre-configured code and a pre-configured nib, an XIB file, which is the user interface. And somehow Apple has pre-configured you with a pointer called window that's apparently going to point to the actual window on the screen so that you can actually control it and put stuff there. Strong and non-atomic, we'll come back to strong, but this somehow relates for now to pointers. Non-atomic just means that you're not writing multi-threaded code here. If you actually said that this is an atomic property, Apple or Xcode would add some additional source code to the getters and setters so that you're accessing this variable bar or window atomically. And long story short, that's just not necessary. And if you haven't taken 161 or 61 and aren't quite familiar with atomicity or threading, don't worry, we'll come back to that, but not in much detail in this class. All right, and how about this one here? View controller. What is a view controller? Yeah, Dan. Good, very good. It controls the view. All right, so what does that really mean? So this is the C in MVC. Apple slightly confusingly calls these things view controllers, but it's just controller, really, but specifically a controller that's designed to operate on a view. And this pointer is going to be the mechanism via which the app delegate, recall, which is the class that at this moment in the story is in charge of the application, is somehow going to further pass control of the application onto code that you wrote. So this is an oversimplification, but generally you won't write much code in your app delegate. Most of the code that you write, certainly for Project 2, will be isolated to your own view controllers, your own models. It's the app delegate that ultimately hands control off to something that you really have written yourself. And that's an oversimplification in that we'll see in a second there are some methods in app delegate that you yourself might want to implement, but those relate to things like backgrounding and force quitting and the ability to actually save really important state before the user hits the home button or turns off the phone or something along those lines. So any questions about this M file? Do speak up. No dumb questions. If you're confused now, the rest of the class is not going to be that useful. Anything at all. All right, so in the M file, thankfully, it's mostly comments. All right, let me close this window on the right-hand side. All the green is comments, but these are the methods. We'll call them stubs. Stubs in that they're really just placeholders that you can delete entirely or start filling in these blanks. And these fairly long-named methods are things you can implement that, again, implement some low-level iOS functionality. How to handle backgrounding, how to handle forced termination. What's nice about iOS is that it allows you, the dev, a last-minute opportunity to quickly save state, to quickly close a database connection, any maintenance that you might want to do so that the application, next time it starts, maybe resumes where you left off, it can all be done at this particular place. But code controlling your views, talking to your model, doesn't generally belong here. Because the method that you might tweak on occasion is this first one. So the name of this method, here's a little quiz question. What is the name of this method? Or the, yes?
Application did finish launch with options.
Good. And if you're writing this in prose, you would actually include the trailing colon. So this kind of detail you'll start seeing in the documentation. So that's the name of this method, or the selector, which is similar but different. We'll get back to those before long. So what's going on here? So there's not all that much commenting. Apple put a comment here, which is essentially an instruction to you, the developer, put stuff that you want to add to this here. But what are these other lines doing? Well, on the right-hand side, actually, rather than me keep talking, what's this doing in the square brackets here?
Allocates memory for a UI window.
Perfect. Allocates memory for a UI window. So it specifically instantiates that object. In it with frame, this is now like the constructor that languages like PHP and Java have. And what is it doing? Well, it's initializing it with something known as a frame. Think of it as a picture frame. It's some rectangular dimensions. Where are we getting that frame from? Well, UI screen, main screen is what kind of method? What kind of method is main screen apparently? Class or instance? So it's apparently a class method because, again, there's no mention of alloc, and I have no mention of UI screen until this moment in time. So UI screen must be a class, and passing in main screen's message means give me some kind of pointer or reference to the so-called screen. So another representation of the glass. Bounds essentially returns the dimensions of that screen. So what we're saying in this whole line here to the right of the equal sign, allocate a window and tell that window that your bounds are from here to here, or whatever the shape of the device actually is. On the right-hand side, what is this doing? Self.window equals. So it's setting the property called window inside of self, my app delegate object, to that value. But more specifically, the dot notation in the equal sign means what method is getting called, or what message is actually being passed. Jason? Set window. So there is somewhere underneath the hood a method called set window that was probably automatically synthesized, written for us, not manually, so that this setting from right to left would happen. Jason?
So is this essentially, this is like the bound, if you're working on an iPhone, it's the dimensions of the iPhone screen, but if you're, is that what this is?
Exactly. It's the bounds of the iPhone or the iPad screen.
Or if you're mirroring like the TV or whatever.
Yes, that's another notion of a window. You can have another, or rather another notion of a screen could be an external via Wi-Fi or physical cable connection. Exactly. So for the most part, this is boilerplate. You rarely change this until you start doing fancy things like projecting videos on the screen to some other screen, doing mirroring, or the like. Yeah?
Since UI window is being allowed, it has to be an instance method?
Good question. Since UI window is being allocked, it has to be an instance method? Not quite. Alloc itself is a class method because it's being passed to a class before anything's been instantiated, but in it with frame is what type of method? Instance or class? Instance, because it is being passed, albeit in nested form, to what is now an existing object that was returned from that message pass. And just to go back to 3 weeks ago when we first started talking about Objective-C, suppose you're out of memory, and suppose that the alloc call for UI window fails, what gets returned? So nil gets returned. So this seems bad, right? In 50, one of the most common causes for bugs, especially around pset6 time, dictionary, is seg faults, right? When you're dereferencing bogus pointers. But that's not going to happen here. What happens if you nonetheless call init with frame sort of blindly on what apparently could be nil? What happens? It ignores the message. So this is a huge value add of this notion of nil as opposed to null, in that if you pass messages to nil, things won't crash. They will simply be silently ignored. And this allows us to eliminate a whole lot of error checking, for better or for worse, and this nesting of messages so that we can just pass and pass and pass irrespective of whether we get back nil. We can check for nil, in fact, at the very end if we really want to, if self.window itself is nil. All right, so moving on, view controller. So this is essentially the same story, but the instance method we're now calling to initialize what's apparently called a view controller is init with nib name. What's a nib? Yeah. So it's a file containing a user interface. It's the WYSIWYG stuff that we saw 2 weeks ago. Underneath the hood, it's implemented with a file extension called XIB. The useless history there is that it used to be Next Step Interface Builder, NIB. When the tool became Xcode, it became XIB, but you pronounce XIB nib. So, for historical reasons. All right, so what is going on here? This is now assigning a pointer to self.viewController to whatever code it is, apparently, that I am going to now write in this application, in the thing that's actually called viewcontroller.m and .h. This next line here, root viewController gets self viewController. So apparently, inside of a UI window, there is a property that's called root view controller, and it does what it says. This is a property that should be set to whatever view controller should kickstart the whole application. Who should be now handed control of this application? Make key invisible just means make this the key window, which means start responding to finger touches on the screen. Make it visible is obvious. And then I return yes, signifying that all is well. So rarely should you need to touch this particular code, at least for initial applications, but realize that's what now hands control off to you. All right. Any